Okay, everybody, today our goal is to practice some problems from the first half of Chapter 3. So if you're watching this at the time that it originally aired at the end of March, right after spring break 2021, what we did before spring break was we started Chapter 3 and now we've had a whole week off to forget everything. So let's go ahead and do some practice. And it's going to work like this. This is going to be your assignment, so it's not a notes entry. And I want you to work through problem number 1 with me, and then I want you to pause the video and work through problem number 2 on your own, and then when you resume the video you can compare your work with what I do. So let's go ahead with number 1. Find the roots of p of x equals 2x cubed plus 5x squared minus 3x and make a rough sketch of the graph. Okay, so this is what we would call a cubic polynomial. Cubic polynomial functions have degree 3. So you can see the highest exponent is 3. And what we're going to do for this problem is we're going to see if we can factor it in order to find the roots. So the roots are the points where, or the x values where the y value is 0. So we're going to set this equal to 0. And then notice that we can factor x out of all 3 terms. So now we have x times the quantity 2x squared plus 5x minus 3 equals 0. And it just so happens that this quadratic quantity is factorable. It factors into (2x minus 1 times x plus 3). And if it wasn't factorable, you could use the quadratic formula. Even if it is factorable, you can still use the quadratic formula to find the other 2 roots. But since I have 3 factors, what I'm going to do is set each factor equal to 0 and then solve each of these equations. And we get our roots. Roots are also known as zeros. So we have x equals 0, we have x equals 1/2, and we have x equals -3. Now, if I was graphing this function, which we are going to do actually, I forgot, it says make a rough sketch. Those would be my x-intercepts. So I'm just going to go by ones on the x-axis and go ahead and plot those values of 0, 1/2, and -3. Now, in order to figure out a little bit more about the graph, remember it's a rough sketch. What we can do is maybe put another number in there. Let's say we put x equals 2. So let's find p of 2. P of 2 would be 2 times 2 cubed plus 5 times 2 squared minus 3 times 2. So we have 16 plus 20 minus 6, so that's 30. So that would be the point with coordinates 2, 30. I'm going to put 30 up here on my y-axis. So that would be that point right there. Okay. So now I'm just going to kind of connect the dots, and that's my rough sketch. So what you'll notice about a cubic polynomial function is that one end goes down and one end goes up, just like a line, one end down, one end up. And if the leading coefficient is positive, so this 2 right here, the 2 on the term with highest degree, if that's a positive number, then it's like a line with a positive slope where you have the left end down and the right end up. But if that was a negative number, then the ends would be reversed. Okay, now let's take a look at number 2, and I want you to pause the video, work through it yourself, and then resume and compare our work. All right, just like in number 1, to find the roots, we want to set the polynomial equal to 0. The roots are the values of x that have a y value of 0. And in this case, we can factor x squared out of all the terms. In fact, we can factor even more than that. We can factor -2x squared out of all of the terms. That gives us -2x squared times 3x squared minus 7x plus 4. And I'm going to see if that's factorable. 3x times x gives us 3x squared. 4 times 1 gives us 4. If we have minus and minus, everything works out for the middle as well. Okay, so that's factorable. So we can set each factor equal to 0 and solve for the roots. Okay, technically you could factor the 2x squared, the negative 2x squared. You could think of it as negative 2x and x. So technically you get two roots there. You get x equals 0 once, and you get x equals 0 again. So we call that a double root. And it's going to have some significance with the graph. Now I'm solving the other equations. We get x equals 4/3, and we get x equals 1. So we have 1, 4/3, 0, and 0 again for our roots. And now for the rough sketch. First I'm going to plot the zeros, or the roots. So we have a root at 0, a root at 1, a root at 4/3. Okay, that's not really enough to go on. So what I'm going to do is take another number, plug it in. How about if I take -1? So let's find p of -1. That's going to be -6 times -1 to the 4th plus 14 times -1 cubed minus 8 times -1 squared. Sorry, that's all squished in there. So that's -6 minus 14 minus 8, and that's -28. So we have the point -1, -28. So I'll just put that one way down here. Okay, now remember how a parabola opens up if the leading coefficient is positive and opens down if the leading coefficient is negative? This is a quartic polynomial. It has degree 4. That's the highest exponent, and it has a negative in front. It's going to behave like a parabola would. So with a negative in front, it's going to open down on both sides. So what we have here for our rough sketch looks something like this. Where you have a double root, it goes up and touches and turns right back around. It doesn't go up through. So just go up and touch, go right back down, and then go through your other roots. So that's our rough sketch. Okay, we're going to do this process 3 more times or 4 more times for a total of 10 problems. And I'm going to work through one with you and then give you one to practice. This will be our entire assignment for today. So it's kind of a combined video and assignment together. There's not going to be anything else after this video. You'll be done for today. Okay, now we're going to review synthetic division. So it says divide p of x by x plus 1, and we're going to use synthetic division to do that. If you're dividing by x plus 1, you put -1 in the little box that you make for synthetic division. So if it's x minus k, you put k in the box. If it's x plus k, you put the opposite of k in the box. So we're putting -1 in the box, and then we put the coefficients of the polynomial in a row. But if there are any degrees missing along the way, we put a 0 to hold the place. So we have 4x to the 5th, and then we have 0x to the 4th, then we have -2x cubed, then we have 0x squared, then we have 3x, and then we have -6 for the constant. So now it's set up, and what we do is we drop the first number, so we bring down the 4. 4 times the number in the box, that's -4, you write it down, and then you add the column. Take this number, multiply it by the number in the box, you get 4, you write it down, and you add the column. Take that number, multiply it by the number in the box, write it down, and add the column. Take that number, multiply it by the number in the box, write it down, and add the column. Take that number, multiply it by the number in the box, write it down, and add the column. And when you can't go any further, you're done. So, what does this mean? -11 is the remainder. 5 is the constant. -2 is the coefficient on the x term. 2 is the coefficient on the x squared term. -4 is the coefficient on the x cubed term. And 4 is the coefficient on the x to the 4th term. So it's only going to go as high as x to the 4th if you were dividing into x to the 5th. It's going to be one lower than what you were dividing into. So when we put all the x's back in here, we get our answer, 4x to the fourth minus 4x cubed plus 2x squared minus 2x plus 5 minus 11 over x plus 1. That's how we write out the answer if it was just a question asking us to divide. But it could be an answer, or it could be a question that just says, what's the remainder? Or what's the function value? So if you're looking for what's p of negative 1, p of negative 1 is what you get for your remainder when you go through the same process. So that would be negative 11. What that means is if you input negative 1 in the function, your output's going to be negative 11. Okay, go ahead and pause the video, try number 4, and then compare your work with mine. Alright, so if we're dividing by x minus 2, then positive 2 goes in the box, and the coefficients of the polynomial go in a row. So we have negative 1x to the fourth, 4x cubed, 0x squared, 3x, and negative 22. Bring down the first number, multiply it by the number in the box, write it down, and add the column. Multiply that by the number in the box, write it down, and add the column. Multiply that by the number in the box, write it down, and add the column. Multiply that by the number in the box, write it down, and add the column. So we just found out that our remainder is 0. That's significant because when your remainder is 0, it means something went in evenly. 11 is the constant. 4 is the coefficient on the x term. 2 is the coefficient on the x squared term. And negative 1 is the coefficient on the x cubed term. So then to write out our answer, we would have the opposite of x cubed plus 2x squared plus 4x plus 11. And one extra benefit of this problem, just for your conceptual understanding, is that we could now write p of x, our original polynomial, as a product of two factors. It's the product of x minus 2 times the opposite of x cubed plus 2x squared plus 4x plus 11. So it's helpful to know that when you're dividing and you get a remainder of 0, you found factors, and so you can multiply those factors to give you the original problem. Okay, in numbers 5 and 6, we're going to review how we do synthetic division in a synthetic division chart. So this is a shortcut for the synthetic division that we just practiced in numbers 3 and 4. So we have this polynomial p of x, and if we were to divide it by x minus 0 using synthetic division, we would get all of the same coefficients that you see in the problem now, but the 30 would be the remainder. So we would have 1, 1, negative 11, negative 5, and 30. Okay, that's going to be our most important row. That's why I put lines around it, and you can highlight it and make it stand out so that every time you do a new row, you're going back to the numbers in that row. Okay, so remember when we do synthetic division, the first thing we do is we bring down the first number. So if I want to do this row of 1, which corresponds to dividing by x minus 1, I bring up the first number. So bring up the 1. The 1 is the number in the box. So you take 1, multiply it by the number in the box, and add the next number. 1 times 1 is 1, plus 1 is 2. Take 2, multiply it by the number in the box, and add the next number. 2 times 1 is 2, plus negative 9 is plus negative 11 is negative 9. Take that, multiply it by the number in the box, we get negative 9. Add the next number, we have negative 14. Take that, multiply it by the number in the box, we have negative 14. Add the next number, and we have 16. 16 is the remainder. It's also the y-coordinate of the point. So if you were making this graph, you could plot the point 1, negative 16. Okay, let's do the next row. So we bring up the 1 again. 1 times the number in the box, which is now 2. So 1 times 2 is 2, plus the next number in the 0 row gives us 3. 3 times 2 is 6, plus the next number in the 0 row gives us negative 5. Negative 5 times 2 is negative 10, plus the next number in the 0 row is negative 15. Negative 15 times 2 is negative 30, plus the next number in the 0 row gives us 0. So that's important because that tells us that 2 is a root, x minus 2 is a factor. Okay, we're going to complete the chart just doing the rows that we're asked to do based on what was already here. So 3 and then -1, -2, -3. So bring up the 1, multiply by the number in the box, 3, add the next number, we get 4. 4 times the number in the box is 12, add the next number, we get 1. 1 times the number in the box is 3, add the next number in the 0 row, we get -2. -2 times the number in the box, add the next number in the 0 row, we get 24. Even when you go down below, it's the same thing. Bring down the 1, multiply it by the number in the box, we get -1, add the next number in the 0 row, now we have 0. Take that, multiply it by the number in the box, add the next number in the 0 row, we have -11. -11 times the number in the box is 11, plus -5 is 6. 6 times the number in the box is -6, plus 30 is 24. Two more times. Bring down the 1. 1 times -2 is -2, plus the next number in the 0 row gives us -1. -1 times -2 is 2, plus the next number in the 0 row is -9. -9 times -2 is 18, plus the next number in the 0 row is 13. 13 times -2 is -26, plus the next number in the 0 row gives you 4. Bring down the 1. 1 times -3 is -3, plus 1 is -2. -2 times -3 is 6, plus -11 is -5. -5 times -3 is 15, minus 5 is 10. 10 times -3 is -30, plus 30 is 0. Now, don't just do this in your head. You should use a calculator when you realize you get to the point where you might be making mistakes. Okay, I make mistakes too. Hopefully I haven't made any mistakes on this chart, but use a calculator. And we just found another root. So if -3 is a root, that means that x plus 3 is a factor. Okay, so pause and then work on this chart for number 6 yourself, and then just to save a little time, what I'm going to do is fill it in, and when you resume, you'll see all the numbers and you can compare it. And if you have any questions about how I got it, you can go back and listen to what I did for number 5. Okay, so here's the completed chart, and you can see that there is a root at 1 because we got a 0 remainder, and there's also a root at -2 because we got a 0 remainder. Okay, let's see what's next. Next, we're going to practice making an APRR list, and APRR stands for all possible rational roots. And before the break, we learned that there's a theorem about this, and basically it has to do with narrowing down the possibilities of what roots you could have for the polynomial to just a finite list. So these are the potential rational roots, rational meaning like ones that could be written as a fraction, could be 1 and 2 and 3 and 1/2 and 5/2 and things like that. So what we do is we look at the constant, and the factors of the constant give us our potential numerators. So plus or minus all the factors of 30. And the factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. So plus or minus all of those numbers are potential numerators for the rational roots. For the denominators, we look at the factors of the leading coefficient, which is in this case 3. So plus or minus 1 and 3 are the only factors of 3. So for the APRR list, we have to make all the possible fractions out of those numerators and those denominators. So what I do is I put all the numerators over 1, and then I put all the numerators over 3. So putting all the numerators over 1 just gives us 1, 2, 3, 5, 6, 10, 15, and 30. Those are the integers. And now we're going to put them over 3. So 1 over 3, 2 over 3, 3 over 3 we don't need to list because it's just the same thing as 1. 5 over 3, 6 over 3 we don't need to list, it's just the same thing as 2. 10 over 3, we don't need to list. 15 over 3, it's the same as 5, and we don't need to list 30 over 3 because it's the same as 10. So in this list we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2, 24 different rational numbers. Some of those may be roots to this polynomial, but No other rational numbers can be roots, only numbers from this list. So you can pause the video and make the APRR list for number 8, and then resume and see how you did. Okay, so to get our numerators, we need the factors of the constant, which is -6, so plus or minus 1, 2, 3, and 6. Those are the factors of 6. And to get our denominators, we need the factors of the leading coefficient, which is 4, so plus or minus 1, 2, and 4. So the APRR list consists of all the possible combinations of those. So plus or minus, let's put everything over 1. And now let's put everything over 2. So 1 over 2, 2 over 2 is a duplicate, 3 over 2 is new, 6 over 2 is a duplicate. Now let's put everything over 4. So 1 over 4, 2 over 4 is a duplicate, we have 3 over 4, and then 6 over 4 is a duplicate. So there's the entire APRR list. Okay, let's wrap it up. And this might be bonus information because I honestly can't recall if we went over this particular thing in the lessons before spring break. So if we didn't, that's okay. You'll just be able to tack on a little bit of new information today. So it says make the real and non-real table and the general sketches for this polynomial. So a real and non-real table tells you the potential theoretical numbers of real roots and non-real roots. So if you have a quartic polynomial with degree 4, it has 4 roots. If you have a cubic polynomial with degree 3, it has 3 roots. A polynomial with degree 5 has 5 roots, etc., etc. Okay, so some of those roots might be real and some of them might be non-real, but they have to add, for number 9, the roots have to add to 4. And if you recall, we learned earlier that non-real roots always come in pairs, because the way you would find them is using the quadratic formula, and you would have something plus or minus the square root of a negative something. So always coming in pairs. So that means you could have 0 of them, or 2 of them, or 4 of them, some even number. So you could have 0 non-real roots, and that means all 4 roots would be real. That's one possibility. You could have 2 non-real roots, and that means the remaining 2 roots are real. Or you could have 4 non-real roots, and that means there are no real roots. So these are just the 3 possibilities, and for each problem it's just going to be one of those 3. For the general sketches, for this problem, because the leading coefficient is negative, and because it's quartic, it's going to have both ends down, just like a parabola. Both ends down if it has a negative leading coefficient. So if it has 4 real roots, it goes through the x-axis 4 times. So there's your general sketch. If it has 2 real roots, it goes through the x-axis 2 times. So you could make your general sketch like that. And if it has no real roots, it doesn't go through the x-axis at all. So you have to make it down below, like that. Okay, you can try number 10. So this one's cubic, it has a total of 3 roots. But still, non-real roots only come in pairs. So for the non-real roots, it could be 0 non-real and 3 real. Or if it's not 0 non-real, it would be 2 non-real and thus only 1 real root, because the total number of roots is always 3 for this kind of problem. And then for the sketches, because you have 2 rows, you're going to have 2 sketches. Because you have a positive number right here, the end behavior is going to be left end down, right end up, just like a line with a positive slope. So if it has 3 real roots, it's going to look something like this. And if it has 1 real root, it's going to look something like this. These are just rough sketches. They're not all going to be exactly like this. By the way, if that leading number was negative, then you would turn these graphs upside down. And on number 9, if that leading number was positive, then you would turn these graphs upside down. Okay, so that takes care of our kind of practice and review for the things that we were looking at before spring break. So that was your whole assignment for today. Thanks, everybody.